Hi students, today we are solving the remaining problems on rotational dynamics. Problem number 16. During a stunt, a cyclist considered to be a particle is undertaking horizontal circle inside a cylindrical well of radius. That means here radius r is given. R is equal to 6.05 meter, that is the radius. If the necessary friction coefficient is 0.5, means this is the friction coefficient, that is mu s is equal to 0.5. How much minimum speed should be the stunt artist maintain? So we have to find the phi minimum. So we can write here phi minimum speed. Phi minimum is equal to question mark mass of that artist, that is m is equal to 50 kilogram. Yes, if she or he increases the speed by 20% that of the first speed, that means this is the second speed, so we can write phi2 is equal to how many? 20%. That means phi1 plus 20% that of the phi1. That means we can write phi2 is equal to this 1 plus 20%, that means 1.2 that of the phi1. Phi2 is equal to how many? 20% that of the phi1. So we can write 20% means 0.2. We can write here 0.2. So phi2 is equal to 1.2 phi1. Yes, how much? 20%. How much will the force of friction be? So we have to find out their force of friction, that is Fs is equal to question mark. So first we are calculating the phi minimum, and second Fs, that is the force of friction. So for horizontal position of that rod, phi minimum is equal to, so phi minimum, already we know the formula. Phi minimum is equal to under root 2 rg. This is the formula for minimum speed. So phi minimum is equal to under root 2 rg. So put that magnitudes, under root 2 into r is given 6.05 into g is equal to 10. You can write there small g is equal to 10. Okay, so multiplication of these, all these, 2 into 6.05 into 10 is equal to multiplication of all these 121. So phi minimum is equal to 121 square of 11, so 11 meter per second. This is the minimum speed, first minimum speed. So this is the minimum speed should be the stunt artist maintain, and secondly we have to find their force of friction, that is Fs. Fs is equal to what? Formula Fs is equal to mg, mass into acceleration due to gravity. So m is equal to mass of that artist is given 50 into 10. That means Fs, force of friction, is equal to 500 Newton. So both answers are given. Phi minimum is equal to 11 meter per second, already we calculate, and second Fs, force of friction, is equal to 500 Newton. This is the 16th problem. Then next we go for the 17th, a pendulum. Problem 17th, yes. A simple a pendulum consisting of massless string of length 20 centimeter. That means here a length of that pendulum, L is equal to how many? 20 centimeter. Convert that into meter. We can write there 0.2 meter or 20 into 10 raised to minus 2 meter. Both are same, 0.2 meter. And a tiny bob of mass. That means here mass of that bob is given. M is equal to, we can write here, M is equal to 100 gram. That means convert that into kilogram, 0.1 kg or 100 into 10 raised to minus 3 kg. Okay, next is set up as a conical pendulum. Its bob now performs 75 rpm. That means this is the frequency. N is equal to 75 rpm. SI unit of frequency is rps, revolutions per second, but here revolutions per minute given. So we can write N is equal to what? 75 divided by 60, that is rps. We are converting that into rps. Okay, calculate the kinetic energy. So here we have to calculate kinetic energy. Ke is equal to question mark, and second, increase in the gravitational potential energy, that is delta pe, gravitational increase in gravitational potential energy. We have to calculate that also. Use pi square is equal to 10 given, and second, cos theta, that also given. Cos theta is equal to how many? Cos theta is equal to 0.8. This is the given data. Here we have to calculate kinetic energy and increase in gravitational potential energy. So first we go for the kinetic energy. For kinetic energy formula, I can write here kinetic energy is equal to Ke is equal to half mr omega square. This is the formula for kinetic energy. So how to calculate that? Kinetic energy is equal to half mr square. So in given data, m given, r is not given here. Okay, r is not given. So how to calculate r? R is equal to, so first we go for this conical pendulum. Suppose this is conical pendulum. This is length of that string, and this is the r, radius. Okay, this is theta. So how to calculate that r? From this diagram we can write sin theta is equal to what? Sin theta is equal to r upon l. R upon l. So r is equal to what? L sin theta. R is equal to L sin theta. This r is equal to L sin theta. But what about the magnitude of sin theta? We know the formula for sin theta. Sin theta is equal to under root 1 minus cos square theta. Because cos theta is given here. Cos theta is equal to how many? Cos theta is equal to 0.8. This one. So sin theta is equal to, sin theta is equal to 1 minus cos theta is equal to 0.8. That means 0.8 bracket square. So sin theta is equal to what? So sin theta is equal to 1 minus 0.8 square. That means this calculation 1 minus 0.64. Yes, so 0.36. So sin theta is equal to what? Sin theta is equal to 0.6. Now we are using that formula, that is Ke, kinetic energy is equal to half m is equal to given. M is equal to how many? M is equal to 0.1 in given data. M is equal to this. M is equal to 0.1. And what about the omega? Omega is equal to, already we know omega is equal to what? 2 pi n. 2 pi into n is equal to how many? N is equal to 75 upon 60. 75 upon 60. So we are using that Ke is equal to, kinetic energy is equal to half m is equal to 0.1 into mr. R is equal to, we calculate that r, mr omega square. R is equal to how many? R is equal to, we are calculating that r. So r is equal to what? R is equal to, here formula we write that r is equal to L sin theta. So r is equal to, L is equal to given, L is equal to what? 0.2. and sin theta is equal to, already we calculate this one, 0.6. That means r is equal to what? 0.12. 6 into 2, that is 12. 0.12 meter, that is the magnitude of r. Use that here. Kinetic energy is equal to half m r, or 0.12 into omega square, this omega square. So we can write that as 15 fours are 16 and 60, and 15 fives are 75. This 2 twos are 4. That means omega is equal to what? 5 pi by 2. This is the magnitude of omega, and square of this omega square is here. So kinetic energy is equal to half into 0.1 into 0.12 into omega is equal to 5 pi by 2 bracket square, 5 pi by 2 bracket square. So we can write that 0.1 as like this: 1 by 2 into 1 upon 10 into 0.12 into 25 pi square divided by 4. Okay, pi is equal to, we can take that pi is equal to 10. So we get that answer as 1 by 2 into 1 upon 10 into 0.12 into 25 into 100. Pi is equal to pi square is equal to 10. Sorry, pi square is equal to 10. That is given here. Pi square is equal to 10. 10 divided by 4. When we calculate this all, then we get the kinetic energy K is equal to 0.045 joule. This is the kinetic energy. And secondly, we have to calculate there the potential energy, increase in gravitational potential energy, delta PE is equal to formula mgl in bracket 1 minus cos theta. This is formula for increase in gravitational potential energy. So m is given 0.1, z is equal to 10, l is equal to, that also given, 0.2 in bracket 1 minus cos theta, that also given, cos theta is equal to 0.8. When we calculate this all, then we get the increase in gravitational potential energy is equal to 0.04 joule. This is our second answer. First answer is kinetic energy, and second one is the increase in gravitational potential energy. Yes, kinetic energy is equal to 0.14 here given, 0.14. That means this answer is correct. 0.045 joule in joule, that is given, and potential energy 0.04. That means there is print mistake there. This answer is 0.045 joule. Okay, then the next problem we are taking, that is the 18th number. This one, the motorcyclist. 18th number. A motorcyclist as a particle is undergoing. A motorcyclist as a particle is undergoing vertical circle inside a sphere of death. The speed of motorcycle varies. Look here. The speed of motorcycle varies between 6 meter per second to 10 meter per second. That means, suppose this is vertical circle, this is A position and this is B position. That means phi A is given. Phi A is equal to how many? Varies between 6 meter per second, and phi B means velocity at this point. Phi B is equal to 10 meter per second. Then calculate the diameter of sphere of death. We have to calculate here diameter D is equal to question mark. Diameter of that D is equal to question mark. Diameter of the sphere of death. How much minimum value are possible for these two speeds? So we have to calculate phi minimum at these two positions, phi A and phi B. So phi A minimum is equal to question mark, and second phi B minimum, that is also is equal to question mark. First we go for this diameter. So we know the formula, final velocity, that is phi b square minus phi a square is equal to 4rg. This is the formula, and from that formula we can determine the radius r, and 2 into r means that is the diameter. So phi b is given, phi also given, g also we know. So phi b is equal to 10 square minus phi a is 6 square is equal to 4 into r into 10. G is equal to 10. We can write there G is equal to 10. So this 100 minus 36 is equal to 4 into r into 10. So r is equal to what? This 100 minus 36 means 64. 64 divided by 40. 10 into 4 means 40 is equal to, r is equal to 1.6 meter. That means radius r is equal to what? 1.6 meter. From that radius we can calculate diameter. Diameter d is equal to 2r. So 2 into 1.6 means 3.2 meter. This is the first answer. What about diameter? Diameter is equal to 3.2 meter. Then we have to calculate the phi a minimum, that is the velocity at a position, minimum velocity at a position, and minimum velocity at b position. Already we know formula for that, at top position, and this is bottom position. So for first we calculate the velocity at top position, phi a minimum. Formula for that, phi a is equal to under root rg. Put the magnitudes. Already we know the magnitude of r. R is equal to how many? 1.6 into g is equal to 10 is equal to under root 16. That means phi a minimum is equal to 4 meter per second. Minimum velocity at top position, that is a position. And second, phi b minimum is equal to what of the minimum velocity at bottom, that is the under root 5rg. 5rg is equal to under root 5 into 1.6 into 10. So phi b minimum is equal to 5 is 6 into 10 means 16, and we can take that 4 under root 5 meter per second, and we can calculate the under root 5, finding the magnitude of under root 5. But already here answer given here, that is phi 2, that is phi b minimum. Phi b minimum is 4 under root 5, where this also correct, or you can find the magnitude of under root 2 and we can calculate that also correct. So phi b is equal to what? Phi b minimum 4 under root 5 meter per second, and phi a minimum 4 meter per second. And already we calculate the diameter of that. Diameter d is equal to 2 into r. So 2 into r 1.6, 3.2 meter. This is the 18th problem. Then the next 19 number, a metallic ring of mass. Okay, a metallic ring of mass is 1 kg, has moment of inertia. So mass is given, m is equal to 1 kg, has moment of inertia, that is I given, I is equal to 1 kg meter square. When rotating about one of its diameter, it is molten and remolded into a thin uniform disc of the same radius. That means radius is same for that ring and disc, radius same. How much will be the moment of inertia be when rotated about its own axis? So first we go for this. Suppose this is a ring. Radius of that ring is equal to, and radius of the, suppose this is after molding, this is the disc that converted into disc. Disc means like this. This is disc, both having the same radius. Okay, so in that case, moment of inertia I is equal to, we can write that formula, mr square by 2, and that already given, that is 1 kilogram meter square moment of inertia of that. Okay, and in this case when that is molded into a disc, then I2 is equal to also mr omega square by 2. Here this m remains the same. That means in both cases mass and radius, this mass and radius remains the same or would be same, and that's why I1 is equal to I2. Why I1 is equal to I2? Because I1 m and r, here also m and r, magnitude of m remains same and magnitude of r also remains same. In that case we can write m1 is equal to m2, and that's why we can write I2 is equal to 1 kg meter square, because I1 already given, this is I1, so I2 also is equal to 1 kg meter per second. This is the next problem, that is 19 number. Remaining 3 problems are remaining, that we take in next lecture. Thank you.